In this video, I want to demonstrate how to work on all those time value or money questions in Chapter 4 in Excel. The examples we are using here are the same questions we used in the lecture notes. I would highly recommend you read the lecture notes or the textbook or watch the lecture videos first and then watch this video or look at the Excel templates and try to understand how to work out all these questions in Excel. We start with making the timeline to understand the cash flow patterns. So for example, we just have to fill in the cells with the time and the cash flows involved. This is a single cash flow, and then we have an annuity with even cash flows, and this is a stream of uneven cash flows. Now, to calculate the future value, we can try to set up the future value formula by ourselves. So, for example, if we want to calculate the future value of $100 in 3 years, what we want to do is future value equals to the present value of this $100 multiplied by 1 plus I, the interest rate at the power of 3. So if you click on this cell, you notice this is the formula used to calculate this future value. And you also notice that for B37, which is the cash flow here, in front of the row number, there's a dollar sign. Also in front of the column, there is also a dollar sign. Same thing with the B36, which is for the interest rate, because for all these results, we're trying to use the same present value, same interest rate, and the only thing changed is the number of years. You can also try the function wizard. To do that, you click on this FX, and among the financials, you can try to search for FV, and this is the results. Then we see this pop-up window, which is the same as what you have here. Now you can type in 10% for interest rate, 3 years, 0 payment because this is single cash flow, no other payment involved. Negative 100, so that we'll have a positive future value. And then we'll get this future value result. Or you can try to use the FV function directly. To do that, simply type in equals to FV, and Excel will tell you what numbers you need to input. So the first one is the rate, interest rate, 10%. Second one is number of years, 3 years, 0 payments, and I'm putting a negative 100, and that's it. So to summarize, you can set up a formula to calculate the future value. You can use the function wizard, or you can just use the future value function directly. Either way, you should get the same results. And then you can try to calculate the future value under different interest rate and different number of years. You should have a table of different results here. And by making a graph based on all these different results, you can see that the future value, of course, increases with the number of periods. And also, as we discussed in the lecture, this relationship is non-linear. So this is an exponential relationship instead of a linear relationship. Now let's look at the present value calculation. If you have $100 at the end of the 3rd year, and then if we want to discount it back by 1 year, because the difference between year 2 and year 3 is 1 year here. Present value is this $100 divided by 1 plus the interest rate, 1 plus 10% at the power of 1, which is 3 minus 2. Now, if we want to find out the present value today at time 0, between year 0 and year 3, there are 3 years. If we want to find out what is the present value of this $100 in 3 years, one way to do it is to use the function wizard. So just click on the FX, and then under the financials, you can search for the present value, and that's it. And then you can input, for example, 10% interest rate or 0.1, and future value is 100. So this is just like what's captured here. Okay, so once you do that, you can calculate the present value, and that is $75.13, same result as here. So no matter whether you are trying to input the formula by yourself or use the function wizard, you get the same result. And of course, you can also try to use the PV formula directly. So if you click on this number, you can see to get that number, the formula you used is the PV function. And so to demonstrate, I'll just try to do this again. I'm trying to calculate PV, so equals to PV, and I'm trying to input the numbers, input the variables now, and you see they give you the hint. Okay, first variable you want to input is the rate, interest rate, which is this, right? And the second number is the number of period. In this case, we have 3 years. So I can just type 3, or I can just click on this number, the 3 here. And in this case, there's only one future value, and there's no other payment, so I can just put a 0. And future value is this $100. And I want to put a negative number here just to differentiate the directions of the cash flows, so that my PV result will be positive. You do notice here they skipped the payment, so either you put a 0 or you just skip the payment, leave it blank. You do see 2 commas here. By now you should be pretty familiar with the PV or FV calculations now. For a single cash flow, you can either just input the formula by yourself, like future value here is the present value multiplied by 1 plus I at the power, or the present value is the future value divided by 1 plus I at the power of n. Or you can use the function wizard, find the PV or FV function, and start inputting the value of these variables. Or you can just use the PV or FV function directly. Now, to calculate the number of years, or say the time needed for your investment goal, in this case to double your investment, so you have from $1 to $2. What you want to do from the function wizard is the NPER, which is the number of period function. And so to find that, again, go back to the formula wizard, and within the financials, you can type in NPER, and from the first result, and then you can start inputting, which is what you see here. Or you can use the NPER function. So to demonstrate, I'll just type in NPER, and now I know the first number I want to input is the interest rate. Second number is payment, which is 0 in this case because there are no other payment involved. Present value will be $1, and then the future value will be a -2. Or you can use a -1 here and +2 here. So as long as these two, PV and FV, have different signs, you should be fine. To solve for the interest rate, in this case, what is the rate of return that you need to make your $1 investment double in 3 years? From the function wizard, you can find that from financial, you can find the rate formula, and first one here, same thing as what you have here. Input the numbers, click on OK, you can solve this, or you can just type in the formula directly. So equals to rate, and then you input the 3 years and the 0 payments, $1 becoming $2, -1 here, +2, or +1 here, -2, as long as 1 is positive, the other one is negative. It doesn't matter which one is positive, which one is negative. For all these results, I would recommend you to just click and look up at the formula bar and see the formula they use and the variables they use. So far these are about a single cash flow. What about annuities and multiple cash flows? For the annuity future value, to explain how for the annuity future value, remember annuity future value is the total future value of all the cash flows, or say all the payment involved in this annuity. So when we have 1, 2, 3 payments here, each payment we calculate the future value. You do notice the first one, because it can compound for 2 years. So 3 minus 1 is the n here, and here 3 minus 2 is the n here. So you calculate one by one, you sum them up. Notice the sum function, sum all these three up, you get the total future value. Apparently this is the very basic way to do it, and also a very time consuming way. To make it more efficient, we can try to use the function wizard. And now if you get the same future value function that we used before, you do see here now we have payment as 100. So now we have a 3-year annuity, each payment being $100. Click on OK, you should have the future value result. Or you can just directly type in future value and 10% interest rate, 3 payments, each payment is $100. I want to put a negative sign in front of that payment amount so that my future value result will be positive, and I get the same result. Okay, present value, same idea. Present value of this annuity is the total present value of all the cash flows involved in this annuity. So you do notice in this timeline, every payment here, we calculate the present value. Okay, for example, 7513 is the present value of this $100, which is discounted 3 years. Now you sum all these 3 numbers up. Notice the sum function, and total present value for this whole annuity, $248.69. You can use the PV function from the function wizard here. And again, you notice that now we have a payment of $100, and we don't input anything for future value here. And then click on OK. The present value is $248.69. I can also just do it directly, equals to present value, and then I input interest rate, number of years, and a negative 100. I don't even have to put a 0 as FD. By default, if you don't input anything, Excel will take it as 0. What if it's annuity due? Now with the annuity due, you can also try using the formula directly. So you calculate the future value of every one, sum them up, or you use the function wizard. You do notice here now with annuity due, for the type, you input a 1. So type here is a value representing the timing of the payment. If it's 0, then we have an ordinary annuity. Each payment is received or made at the end of each time. But if it's 1, then this is telling Excel each payment is made or received at the beginning of the period. So the only difference between this one and which you have here is, for the ordinary annuity, you can just skip the type or just put a 0 here. For the annuity due, you put a 1 as the type, and click on OK. You get the future value. This is 10% higher than the result you got here for the ordinary annuity. Remember in the lecture we talk about how future value of annuity due is 1 plus I times of the future value of the matching ordinary annuity. And if you want to do this directly, future value, and to save some time, I just input the numbers directly, 10%, 3, and negative 100, and 0 is the future value, so I'm skipping that, and now I'm just typing a 1 as a type, the last variable, and that's it. Again, for the ordinary annuity, I don't even need to input the type, the value for type. You see the difference between the future value of annuity due and ordinary annuity. Same thing with the present value. You do see for the annuity due, type is 1. You can also try present value of 10%, 3 years, negative 100, skip the future value, or if you want, you can put 0 as a future value and a 1 here. If I remove the 1, or if I put a 0 here, that's for the ordinary annuity. Hey, now what if we have uneven cash flows instead of the nice even cash flows in the annuity? So in this case, you have different amount of cash flows. Well, following the principle, what we can do is we calculate the present value of each every one independently or say separately. For example, 247.93 is actually the present value of 10% discount rate, 2 years, and 0 payments, and a negative 300. So that is if I want to calculate the present value of this $300 separately. And if I want to calculate the present value of this $300, the only thing is now it's 3 years. 225 is what you have here. Hey, so you get all the 4 present values which you calculated one by one. You sum them up, you get the total present value. Apparently, this is also very time consuming. You can set it up in a column, so 1, 2, 3, 4 years, each every year, or the cash flows. The good thing about setting it up this way is you can just copy and paste the formula. So as long as I have the formula of this first one set up correctly, now I can just copy and move over, and I don't have to type the formula one by one. For each every one, I just copy and formula over. To do that efficiently or accurately, you do notice that in this formula, the cell B477, which is the interest rate, is fixed. And so we have the $ and $ just to tell the Excel, no matter what, you are always using this interest rate. You are not using any other one. If I don't do that, so if I don't do the $ and $, I want to show you the difference. The first one is not affected, but now if I want to copy and paste the formula, you see these numbers are not correct. For those who have some experience in Excel, you understand this is about the so-called absolute versus relative reference. So we are trying to refer to that same cell when we try to calculate different present value in different rows. You can also use the function wizard, so you need to use the NPV function to do that. Under financial, we can try to search for NPV. We get the first one. Okay, now the rate, we can just say 10%. For the values in that value 1, either you want to just type in all these numbers. Well, in this case, there are only 4, so it's not too much. Or you can just tell Excel, hey, we are trying to select from here. So from B481 to B484. This may be a little bit faster than typing the numbers by yourself, right? So click on OK, you should get this result. Or you can just do it directly, NPV, and now type in 10% interest rate, or you can just click on that interest rates and select all the future cash flows, and that's it. I do have to point out that a common mistake is to include all the cash flows like this. You see 2 different results, and this is not correct because it somehow include from year 0 all the way down to year 4. we want to include only the future cash flows, so we want only from year 1 to year 4 in this case, and this is the correct. Next subject is the effective interest rate. So to start, we have 10% for the whole year, and then if we pay semi-annually, then 10% divided by 2, we get 5%. And to calculate the effective rate, you can try to use the formula. So this is strictly following the EFF formula. There is also an effective rate function in Excel. So just click on this, and under the financial, if you just want to type EFF, the first one, effective annual rate. So what you want to input is the 10%, and semi-annual compounding, so that's twice a year, and effective rate is 0.125, which is 10.25%, the same as this one. So again, either you can just input the formula by yourself, or you just use the effect function in Excel. Now, with different compounding frequency, depending on the question you are looking at, for example, what is the future value after 5 years under 12% annual compounding, pretty straightforward future value calculation. You can try this by yourself and check with the result here. Just click on this, you can see how they input the numbers. And if we are talking about semi-annual compounding, then instead of using 12% compounding for 3 times, now we are using 6%, which is 12% divided by 2, and compounding by 6 times, which is 3 multiplied by 2. With quarterly compounding, now 3% for 12 times, so this is a new future value. Monthly compounding, that will be 12 times, each month 1% interest rate, you get a new future value. And if you see the difference across all these numbers, higher compounding frequency, higher future value, which also means higher effective annual rate. Now, if we look at amortization problem, the first thing about amortization problem is you want to calculate the payment from this loan. So if we have a $1,000 loan that needs to be repaid in 3 payments, when the interest rate is 10% per year. So each payment will be this much, and that's the payment function in Excel. So if you want to try, just type in equals to payments, and according to the hint from Excel, you want the interest rate of 10%, three payments, and a present value of 1,000. You want to put an active sign now, and that's it. No future value, or say 0 future value. Then in this amortization schedule, you notice how they set it up. We start with the principal of the loan, $1,000. First year, the interest will be principal multiplied by the interest rate. So principal multiplied by the interest rate. Again, you notice they use a dollar sign just to tell, hey, we're always using the same 10% interest rate from here. If the payment is 40211, which is same thing as here, so we are always using the same payments. You notice the dollar sign and dollar sign. Within the first payment, $100 will be paid off as interest. The rest is the principal. So the principal amount here is actually the payment minus the interest. Now, after you make this payment, your principal will go down by this much. So your ending balance after first year, after you make your first payment, will be your beginning balance minus the principal paid. So that's why you have B602 minus E602. And for the next year's beginning balance will be the same as last year's ending balance. So that's why this number is actually the same as F602, which is here. And then this number generates an interest of 10%. Interest payment will be this multiplied by 10%. For each every cell here, if you want to know how these numbers are calculated, you just need to click on it and look up at the formula bar and understand how they are calculated. After the second payment, the balance will be lowered by another 332.33, so it will go down to 365.56, which will be the beginning balance of the last year. And eventually, after you pay off all the payments, 3 payments altogether, the ending balance should be 0. That means this loan is completely paid off, 0 balance left. And if you sum up all the interest payment number, it will be the total interest paid here. And if you sum up all the principal paid, it will be this total principal paid here. And of course, if this loan is to be paid in 3 years, then total principal paid should be the same as the amount that you borrowed at the beginning. The total payment will be these 3 numbers added together, which is also the sum of total interest payment and total principal payment. So this is to explain to you how the amortization schedule is set up and how each every year, or in your mortgage case, each every month, how the interest payment is calculated, how the principal payment is calculated, and also how the remaining balance is calculated. If you use the numbers in this table, you can draw a graph to show that the portion of interest actually goes down while the portion of the principal payment goes up. If you have another loan, let's say a 30-year mortgage, same idea, you can construct the amortization schedule. In this case, if we start with $1,000 30-year mortgage, 10% per year, you can start by calculating the payments using the payment function. To demonstrate how to make the whole amortization schedule, we'll start with the beginning balance of this loan. I can just type in the $1,000, and the payment is the same payment that we just calculated, and I want to use a dollar sign and a dollar sign just to show, hey, it's always going to be the same amount over the next 30 years. So if I copy that, copy and paste, and then for the interest payment for the first year is the beginning balance multiplied by the interest rate. Now I also want to have the dollar sign and dollar sign just to show, hey, we're always using the same 10% interest. Payment minus the interest payment will give me the principal payment. And so my ending balance, my remaining balance after the first year is almost the same as the beginning balance, just $6 shorter. Then second year, my beginning balance of the second year will be the same as the ending balance of the last year. And now I can actually try to copy and paste. You're looking at a bunch of zeros now. That's totally fine. And these numbers so far look very weird, but that's totally fine as long as we finish the whole thing. Ta-da! Ending balance after 30 years, 30 payments will be 0, and each every year you have the beginning balance, total payment paid, the portion that goes to the interest, the portion that goes to the principal, and remaining balance. And you do see the portion that goes to principal goes higher and higher, and the portion that goes to the interest goes lower and lower. So this video is a review of all the Excel functions involved in Lecture 4, including the present value, future value calculation for a single cash flow and also for annuities, ordinary annuity and annuity due, and uneven cash flows. You can try to input the formula by yourself. You can try to use the formula wizard. You can try to use the built-in functions such as FV, PV, and PV functions. Either way, if you are not very familiar with Excel now, this template is a good resource for you to try to practice and get familiar with all these functions And you will definitely use a lot of these functions throughout this whole semester for the valuation, for the capital budgeting, for a lot of stuff that we need to do in finance.